Welcome to Study Loop.
They give you the electric field and they want to know the magnetic field component of the wave and some information about the wave in general. So let's remember that the magnitudes of the electric field and magnetic field are related by the speed of light. So we have in general EM divided by BM being the magnitude is equal to the speed of light. And other useful relation is that the wave number and the speed of light is related to the angular frequency. And with this two information, we can start tackle the problem. So the first one, we want to know what is the magnetic field. And from the first relation here, and K is wave number, the first relation we can discover omega. So let's do it for part A. Omega is 1.00 times 10 to the minus 6 times speed of light, 3 times 10 to the 8. This is 3 times 10 to the 14 rad per second. And from the first relation, we have the magnetic field amplitude is EM over C. So this is 5 divided by speed of light. This is 1.67 times 10 to the minus 8 Tesla. And then we can write the component of the magnetic wave. The component, because it is a sine wave function, we see that direction of propagation is in minus z because of this guy here. And because we have the component in the y direction, the only way that the magnetic field can oscillate in the x direction. So this is the only component that we have. And with this amplitude, and the sine wave will be exactly the same. It will be 1 times 10 to the minus 6 z plus omega. Omega, now we know how much it is. It's 3 times 10 to the 14 t. Now they want to know some information about the wave in general. First, they want to know what is the wavelength. The wavelength is related to the wave number. So we have that wavelength for part B is 2 pi divided by k. K is this number here inside the sine wave, and this is 2 pi divided by 1 times 10 to the minus 6, and this is 6.28 times 10 to the minus 6 meters. They want to know the period. The period is related to the angular frequency, again by a factor of 2 pi. And the angular frequency here is 3 times 10 to the 14. So this is 2 pi divided by 3 times 10 to the minus 14. Let's confirm here. Yeah, 14 plus 14. And this gives us 2.09 times 10 to the minus 14 seconds. Now, in part D, they want to know the intensity of light. The intensity is related to the amplitude of the electric field. So we have that intensity is EM squared divided by C mu zero square, C mu zero. And now we just need to put the values for the intensity. So the EM is 5 square, speed of light is this, and my mu0 is 4 pi 10 to the minus 7, 4 pi 10 to the minus 7, and this gives us an intensity of 0.0332 watts by meter square. And part E, they want to know parallel to each axis the magnetic field oscillate. We already did this in part A, because the only non-zero component of the magnetic field is Bx, x. So the magnetic fields oscillate in the x direction. And for part E, F now, in which region of the electromagnetic spectrum is this wave? And looking for the wavelength, when we see that, so for F, the wavelength that we got, lambda is 6.28 times 10 to the minus 6 meters, and this is infrared.